Now discuss about Friedel-Crafts reaction. It involves two reactions. The first one is Friedel-Crafts alkylation and the other one is Friedel-Crafts acylation. Start with the Friedel-Crafts alkylation. What do you mean by Friedel-Crafts alkylation? By which we can produce alkyl benzene. What do you mean by alkyl benzene? You can see here in the benzene ring an alkyl group like CH3, that is methyl group, or CH2, CH3, that is ethyl group, or CH3, CH3, an isopropyl group like that has been introduced. And this reaction is called Friedel-Crafts alkylation. And how it is possible? The benzene ring is treated with a alkyl halide RX in the presence of anhydrous AlCl3, which is a Lewis acid, so that you will get alkyl benzene. For example, benzene is treated with methyl chloride in the presence of anhydrous AlCl3 to get methyl benzene, which is commonly called toluene. Like that, the benzene is treated with the ethyl chloride in presence of anhydrous AlCl3 to form ethyl benzene. These are certain examples for Friedel-Crafts alkylation reactions. Now, we will discuss the mechanism of the alkylation reaction. First of all, the alkyl chloride will react with the anhydrous AlCl3 so that the bond between the carbon and halogen will break in a heterolytic manner so as to generate the carbocation R+. Now, this benzene ring will attack the carbocation, that is this pi electron will be shifted towards this carbon so that that carbon becomes electron rich, and where the alkyl carbocation is added so that this carbon becomes electron deficient, and there is a resonance of pi electron to get the resonance hybrid as usual. And finally, the AlCl4- will abstract a proton so that the excess electron will be shifted to the benzene ring, and that is the carbocation, and you will get the final product alkyl benzene. And this is the reaction called the Friedel-Crafts alkylation. Now we will go to the reaction called the Friedel-Crafts acylation. Before that, we will discuss one more case. And if you treated with what is so called the propyl chloride. This is propyl chloride, normal propyl chloride, because normal means it is a straight chain. So whenever treated with the Lewis acid AlCl3, this bond will break. After breaking this bond, you will get a carbocation, but this is a primary carbocation. Since this is the primary carbocation, what happens is there will be a proton shift from this second carbon, and H+ will be shifted to this one so that the second carbon becomes a carbocation, which is a secondary carbocation. And the secondary carbocation is more stable so that the product obtained from this one, that means to the benzene ring, this carbon will be attached and the product become isopropyl benzene, which is a major product, rather than from the primary carbon which is attached to the benzene ring to form normal propyl benzene, which is the minor product. This becomes minor because this is a primary carbocation which is less stable. Now, Friedel-Crafts acylation. The benzene ring is treated with the acyl chloride RCOCl in the presence of AlCl3 to get acyl benzene. This compound is called acyl benzene. This reaction is known as Friedel-Crafts acylation. A typical example is benzene is treated with the acetyl chloride CH3COCl in presence of anhydrous AlCl3 to get the product acetophenone. This product is called acetophenone. So mechanism is in this way. Acyl chloride is treated with anhydrous AlCl3 so that this bond will break in a heterolytic manner to get acyl carbocation. This is the resonance stabilization of acyl ion. Now this acyl carbocation will be added to the benzene ring, and as usual the pi electron will be resonated and you will get the resonance hybrid. And finally this anhydrous AlCl4- will abstract a proton and you will get the excess electron will be shifted back and you will get the acyl benzene as the final product. So this reaction is known as Friedel-Crafts acylation reaction. Okay, thank you. We'll continue.